Hi, welcome to my channel Icon Teacher. I am Satyaprasad. In today's session, we will discuss an important question which is from exercise 1.1 question number 2. Show that the relation R on the set R of real numbers defined as R equal to the set of all ordered pairs A comma B such that A less than or equal to B square is neither reflexive nor symmetric nor transitive. So to solve this type of questions, what we have to do is to give a suitable example to show that the relation is neither reflexive nor symmetric nor transitive. So I am going to teach you a simple technique of how to find out the examples. So let us start with the reflexive relation. So to prove R is not reflexive, now if you choose any ordered pair of the form A comma A where A is an integer, then we cannot prove that it is not reflexive, because generally for all the doublets where A comma A, where A belongs to Z, we observe that if A belongs to Z, then it will not satisfy the example that A less than or equal to A square is false. It will always be true. But if I want to prove that A comma A does not belong to R, then I have to choose an example where A is greater than A square. So the condition for A greater than A square is satisfying will be any proper fraction. So you should be able to choose an example where it should be a ordered pair of the form A comma A where A is a proper fraction. So what we will do is, let us take example half, which is a proper fraction. Half belongs to R real number set, but so I have to distinguish the relation from the real number set, I just put double stroke R so that we can write this R with double stroke as a real number set. Half belongs to R, but half comma half does not belong to R. So since half is less than or equal to half whole square is false. Therefore R is not reflexive. R is not reflexive. So now you can create as many examples as you can to prove the relation is not reflexive. So I gave one such example. Choose any doublet where it is in the form of A comma A where A is any proper fraction. So example half comma half. The other example could be 1 by 3 comma 1 by 3. The other example could be 1 by 4 comma 1 by 4. So any example of the form A comma A where A is a proper fraction. So we can just make a note. Choose ordered pair A comma A where A lies between 0 and 1, or A is a proper fraction. So this is how we prove that R is not reflexive. Now let us prove that the given relation R is not symmetric. If a given relation is symmetric, then how do we prove that a given relation is symmetric? If an ordered pair A comma B belongs to relation, then B comma A should also belong to the same relation. So if we want to prove that the given relation is not symmetric, then what we have to prove is, if A comma B belongs to R, then B comma A should not belong to R. So let us try to prove that R is not symmetric. R is not symmetric. So AB should belong to R and B comma A should not belong to R. So which means A should be less than or equal to B square and B less than or equal to A square should be false. So which means B should be greater than a square. So if you are able to choose an example of ordered pair a comma b where b is greater than a square, then we can prove that the given ordered pair does not belong to R and hence the relation is not symmetric. So let's try to choose an example where b is greater than a square. Suppose we take a equal to say 2. Then b should be greater than a square, so b can be equal to more than 2 square, that is 5 or 6 or 7 or anything. So we can observe that 2 comma 5 belongs to R. 2 comma 5 belongs to R as 2 is less than equal to 5 square is true. But 5 comma 2 does not belong to R as 5 less than equal to 2 square is false. So we can prove that the given relation is not symmetric. Therefore, R is not symmetric. So here also we could see that we can create as many examples as we can, where if we give a value of b which is greater than a square, then we can create as many examples as we can. So R is not symmetric relation. Similarly, if I take the value of a equal to 3, what should be the values of b? It should be greater than 3 square. So it should be 10, 11, 12, so on. Because 3 square is 9, I should choose a value which is greater than 9, that is, it can be 10, 11, 12, so on. So this is how we prove that the given relation is not symmetric. So we can choose as many examples as we can once you know the logic of how to create an example for proving the relation is not symmetric. Now let us try to prove that R is not a transitive relation. R is not a transitive relation. So to prove a given relation is transitive, if the ordered pair AB and the ordered pair BC belongs to a relation R, then the ordered pair A comma C should also belong to the same relation. So if we want to prove that the relation is not a transitive relation, then AB should belong to the relation R, BC should belong to the relation R, but A comma C should not belong to the same relation R. Then only we say that this is not a transitive relation. So we should be able to create an example where the ordered pair A comma B belongs to a relation R, B comma C should belong to the relation R, but A comma C does not belong to the relation R. So which means A should be less than or equal to B square. B comma C belongs to R means B should be less than or equal to C square, but A comma C should not belong to R, which means A less than equal to C square is false. So which means A should be greater than C square. So we should be able to identify the condition where the value of A is greater than C square, and it should satisfy the condition that A is less than or equal to B square and B is less than or equal to C square. So let's try to find out those values where it satisfies all these three conditions. So here, since A is less than B square, we can write this as root A is less than or equal to B and B is less than or equal to C square. So combining these two conditions, so we can write it as root A less than or equal to B less than or equal to C square. And we have one more condition that A is greater than C square. So let's try to make use of these two conditions to find out the suitable examples. So let us not take C equal to 1 because C 1 square will be 1, so we will not get a bigger value. So let's try to take a value, say C equal to a bigger value, say C equal to 2 or 3. Suppose I take a value of C equal to 2, then I should choose a value of A greater than C square. So any value greater than C square can be taken. So 2 square is 4, so I can take a value greater than 2 square, so I can take say 5. 2 square is 4, so I can take 5. So I have taken C equal to 2 and A equal to 5. Now the value of B should lie between root A and C square. So root A is root 5 less than or equal to B square. So B we don't know, and less than equal to C square is 4. So I can choose a value of b less than 4 and greater than root 5. So b can be equal to 3. So let us try to find out this. A comma b is nothing but 5 comma 3 belongs to R, as 5 less than equal to 3 square is true. And similarly b comma c, that is nothing but 3 comma 2 belongs to R, as 3 less than equal to 2 square is true. And what about a comma c? But a comma c, that is 5 comma 2 does not belong to R, as 5 less than equal to 2 square is false. So we could create an example where the values of a, b, c are a equal to 5, b equal to 3 and c equal to 2. So we can create any number of examples like this to prove that the given relation is not transitive. So let's take one more example. Say for example c equal to 3. Then the value of a should be greater than c square. A greater than c square. So the value of a should be equal to any value greater than 9. So let's say 10. So the value of b should lie between root a and c square. So root a less than or equal to b less than equal to c square. So let me take it as root a is root 10 less than equal to b less than equal to c square. C square is 9. And we know that root 10 is approximately 3 point something. So b can be taken a value. So 4 or 5 or 6 or 7, so on. Okay. Still 8, 7, 8. So less than 9, any value less than 9. So if I take a equal to 10, b equal to say 8 and c equal to 3. Let us try to make an example. 10 comma 8 belongs to R, as 10 less than equal to 8 square is true. 8 square is true. And b comma c, that is 8 comma 3 also belong to R, as 8 less than equal to 3 square is 9 is true. Is true. But if you say 10 comma 3 does not belong to R, as 10 less than equal to 3 square is false. Is false. Therefore, R is not transitive. R is not transitive. So we have to write down a rule for the relation to be not transitive by choosing the condition that b should lie between root a and c square and a should be greater than c square. So we can just make a note. R, to prove R is not, given relation R is not transitive, so root a less than equal to b less than equal to c square, and also second condition is that a is greater than c square. A is greater than c square. So similarly, to prove R is not symmetric, you can just make a note. To prove R is not symmetric, choose value of b greater than a square. So I hope all of you understood how to create the examples for proving the given relation is neither reflexive nor symmetric nor transitive. If you like my video, please like, share and subscribe to my channel. Thank you.